This drive contains a very special Linux distribution, and this, as you may or may not remember, is a really special computer. And you might be wondering, okay, Brad, what makes this distribution so special? Well, it completely obliterates the Unix directory structure. It changes it to just 5 base root directories, which, if you're familiar with Linux distributions at all, like any Linux distribution, nothing does that. Except this distribution has been doing it since 2003, actually. What I'm gonna do is try to install it on this PC, hope that there's no strange hardware conflicts, considering this is an already very experimental distribution, and this system is extremely strange. It has 2 CPUs, it has 16 RAM sticks, it's got all sorts of other quirks, so hopefully nothing actually goes wrong, and then beyond that, I want to find out, okay, is this distribution actually practical to use? Like, how the heck does it even work with only 5 base root directories? Booting into the installer gave me a few different options. I could either try out the live system, I could go to a graphical installer, or I could just do it all via the command line. And obviously, have you met me, I chose to do it all via the command line, which was actually a pretty straightforward process. It walks you through the process for the most part, it gives you options to select, and that was simple enough. Okay, cool, so it was all pretty chill, right? I selected the packages I wanted, I made a fresh user account, I gave it sudo access, and by the time I finished all this, it was like 2 AM, so I was thinking, alright, let me just go to bed and I will boot it up in the morning and make the rest of my video, right? Good morning. So I actually did run into 2 different issues with install. One was my own fault for not reading well enough. The other one was somewhat expected. It was related to grub, actually. So what I didn't read was the issues with the current release, and they suggested to download the grub files manually since that somehow didn't manage to get packaged into the release. I downloaded it and that solved that issue, but I also had other issues just related to installing grub on this particular system. Hold up, this is the HP Z820 and I should probably reintroduce it to you. It is actually quite large, it weighs probably 40 or 50 pounds, and with a red next to it for scale, you can probably tell the dimensions of it. Now, it is entirely modular, actually. This is the power supply on top, which just pulls right out. We've also got our drive bays here, same thing, you can just pull them out and swap the drives. We have 2 different Intel Xeon CPUs here, and we have 16 sticks of DDR3 RAM clocked at 1600 megahertz, leading to a total of 96 gigs of DDR3, which was crazy for 2012, but it sucks now. In fact, this thing is so power hungry that I don't even use it as a server, which is what I originally got it for. HP Z820's biggest strength is also its biggest weakness. It's a really cool system with really unique hardware. And when you take an already experimental Linux distribution, well, chances are you might start to encounter some issues. Let me allow past Bread to continue talking. The bigger issue in question here is that GoboLinux has different system directories, which means pointing to things like the kernel all has to be done manually, right? Where does the kernel live? Well, it lives in Gobo's specific system directory for it in the /system hierarchy instead of your normal kernel place. So I had to figure all of that out, link everything up correctly, create a manual grub configuration. That's one issue down, but we are not out of the weeds yet. Okay, so what even is GoboLinux? Well, first of all, you'll notice this is their incredibly cool mascot, but this is a distribution I had actually never heard of before, and I would bet a lot of you haven't heard of it either. It was started in 2002, and it looks as if the first official release was in 2003. One of the founders of Gobo is actually the same person who created HTOP, as well as a bunch of other stuff you've probably heard of like Lua Rocks and the Teal programming language. Gobo is a very experimental distribution, and the entire point is to redefine the file system hierarchy that most distributions have. The traditional Unix file system hierarchy standard is a whole mess of different directories on your root file system where all of your various system files are gonna go. If you're not familiar with it, I do have a video covering the entirety of it, what every single directory is gonna do, but the bottom line here is that for somebody who's pretty seasoned with using Unix-based systems, it does make sense to me at this point. I do find it relatively organized, but I do totally see the point as well of, wait, this maybe doesn't make that much sense how it's organized, let's do a whole new take on it and organize it entirely differently. Okay, so that's a really cool idea, but isn't that going to introduce a ton of problems that have to get solved in order for this to be a real usable distribution that's going to be compatible with other programs? GoboLinux has 5 base system directories. We've got programs, we've got user, we've got system, we've got data, and we've got mount. Now, a couple of those are going to be self-explanatory, but the key takeaway here is that your programs are just going to be stored in one singular directory. That's the programs directory. And to figure out what programs you have installed on your system, all you have to do is list out the programs directory. Now, you may have realized a key flaw with this, which is that programs generally tend to put files in specific directories. Most programs have hard-coded directories that they intend to either put files in, reference, call back to, etc. So what does GoboLinux choose to do about this? Well, they just symlink directories, which on the surface that sort of seems like a strange workaround, but supposedly it actually works really well, and they even claim that that extends compatibility further than some Linux distributions that don't even do this. I have encountered one pretty significant issue, which is that GoboLinux does not have the required driver for this system's Wi-Fi card. In fact, I don't think the HP Z820 even came with a Wi-Fi card originally. This is just using a Wi-Fi card from the era. It's an old Wi-Fi card, and it makes sense that Gobo might not ship with the drivers, even though, if I recall, Arch actually did. So for whatever reason, the Wi-Fi isn't working, I have just switched to Ethernet, problem solved. Okay, I don't think this actually was a driver issue, and let me tell you why. GoboLinux ships with its own network manager called GoboNet. You're not going to have the typical IWCTL or network manager utilities that you're probably familiar with. No, we have GoboNet instead. Now, even though GoboLinux does rearrange the system structure, there shouldn't actually be any change in terms of the kernel drivers present. So I think this issue just happened because for whatever reason, GoboNet was unable to work with this really old Wi-Fi card. So I mentioned that GoboLinux has 5 different system directories: programs, users, system, data, and mount. A couple of those are going to be pretty obvious. For example, the mount directory, okay, that's for mounting. But what actually resides in the other directories? Traditionally, in terms of the Unix hierarchy, you're generally going to have a program split up into all sorts of directories. So for example, user/bin, and then something in etc, and in plenty of other directories depending on the program. However, what Gobo chooses to do instead is give each program its own subdirectory inside the /programs directory, which in a logical way makes total sense. The data directory houses transient data that is used by applications but isn't technically part of those applications, so it's not going to break the rule of all applications going in /programs. Inside, there's a directory called variable, which is equivalent to /var, and there's also a directory called compile, where all data for ongoing compilations is kept. Now, the system directory is arguably the most important directory here, and this is where some of the traditional Unix directories that you're familiar with are going to reside. For example, bin, sbin, lib, and a share directory all live inside the system directory. It also has a kernel directory with our kernel images, our configuration files, and the programs needed to boot. And this is what tripped me up when I was trying to manually install grub. I should have probably realized that, well, because this is a distribution that's going to rearrange the entire hierarchy, of course the kernel is going to be in a different place. But I finally did realize that and found the right path of the kernel image, which is just under system, kernel, boot, and then the name of the current kernel. I pointed to the right kernel, and then I was able to boot just fine. Gobo also uses the file system to index by category, so that way it can find the files needed for a program without having to scan through hundreds of different programs. For example, we've got directories such as /system, /index, /lib, as well as /system, /index, /bin. Now, this is a distribution where you're going to be compiling packages from source, but fear not, GoboLinux has one single command called compile, with a capital C actually, and side note, it seems like a lot of their system commands all have capitals for some reason. So compile is going to use the program's own site to go ahead and download the source, and it's also going to handle dependencies directly by looking in /programs. Gobo uses a system called recipes, which is just directions to compile on how to configure, build, and install the particular program. There's a few commands related to recipes, and they all function in the way that you would expect from a compile from source distro. There's also a number of other commands unique to GoboLinux, and there's a really good wiki reference page if you want to learn those commands. Now, GoboLinux includes its own version of the awesome window manager along with a handful of default programs. So this is definitely usable out of the box. I chose to do a full installation of it, even though normally I would obviously do something super minimal and I would just pull my own DWM build to use. I wanted to actually use the defaults here just to see how it would feel, and it seems as if this is a fully featured system. Gobo has its own custom init system because the developers did not want to use one of the existing init systems. It has GoboLinux boot scripts, which are going to initialize and configure the system, they're going to manage daemons, and they will perform shutdown or any other tasks. Boot up is the primary startup script, and that's what's going to happen when you go ahead and power on the system. Okay, so I'm gonna be honest, using an experimental Linux distribution with really rare and unusual hardware is obviously gonna lead to some problems, so it's no surprise that I had a few issues along the way here. However, I don't really think any of that is GoboLinux's fault, and moreover, GoboLinux does announce itself as an experimental distribution, so of course I'm not gonna be expecting the level of polish that you might expect from something like Ubuntu or Linux Mint or whatever. At the end of the day, is this actually a distribution worth running for the average user? Well, I think it is for the specific type of user who really cares about the hierarchical structure. If this is something that is really bothering you with other Linux distributions having the typical Unix structure with all of the various directories, well, Gobo might actually be the solution, and it's customizable enough, as are all Linux distributions really, but it is customizable enough that you could certainly adapt it to your needs and work with a new Linux structure.